Your F-150 is leaving the showroom floor with 5 factory configurations engineered to quietly destroy your truck long before the odometer hits 6 figures. Most owners have no idea that the exact features they paid extra for are the ones secretly bleeding their wallets dry and turning precision machinery into scrap metal. Ford didn't design these parameters to make your truck last 15 years. They designed them to get the vehicle past the powertrain warranty window so you can buy another one today. I'm exposing 5 factory settings and features that are actively destroying your F-150 without you knowing. Setting number 3 has caused more catastrophic engine teardowns on my shoplift than every aftermarket modification combined. And setting number 1 is so deceptive that millions of owners actually think it is beneficial to their truck when it is doing the exact opposite. Let's get into it. Number 5. The Intelligent Oil Life Monitor, IOLM. We start with the software setting that sets a trap for your engine from day one, the Intelligent Oil Life Monitor. Ford's marketing team heavily promotes this feature, claiming it uses advanced algorithms to track your driving habits and extend oil change intervals up to 10,000 miles or 1 year. They tell you it saves you money and reduces environmental impact. But here is what Ford doesn't tell you. That algorithm is optimized for marketing, brochures, and cost of ownership fleet metrics, not for the physical realities of a twin-high turbocharged or high-displacement engine. When you leave that setting at 100% and let it dictate your maintenance, you are pushing your engine oil far past its mechanical breaking point. I have pulled oil samples from EcoBoost and Coyote engines at the 8,500-mile mark, and the laboratory results are horrifying. The oil is completely sheared down. Viscosity that started at a healthy 5W30 is reduced to the thickness of sewing machine oil, and the total base number, the oil's ability to neutralize destructive acids, is utterly depleted in the 3.5-liter EcoBoost. This extended interval is flat-out lethal. The twin turbochargers spin at over 200,000 revolutions per minute, generating scorching temperatures that literally cook the oil inside the bearing housings the moment you shut the truck off. When you run sheared, fuel-diluted oil for 10,000 miles, you starve the variable valve timing system. Those tiny oil passages leading to your cam phasers become clogged with microscopic varnish and carbon sludge. The hydraulic chain tensioners lose pressure, allowing the timing chains to slacken and violently whip against the plastic guides. By the time your dashboard finally lights up to tell you it's time for service, the cumulative, invisible damage is done. You are grinding your engine bearings to dust and setting yourself up for a $4,200 cam phaser and timing chain replacement. The solution is incredibly simple, and it won't cost you a dime in software updates. Ignore the factory monitor completely. Manually reset your trip odometer and change your engine oil every 5,000 miles or 6 months, whichever comes first, and use only a high-quality, full synthetic fluid with a premium filter. If you tow regularly or idle heavily, drop that interval to 4,000 miles. You are overriding a factory setting that prioritizes corporate emissions compliance over the actual lifespan of your hardware. Number 4. The factory auto start-stop system setting, number 4, is one that Ford markets as a massive fuel-saving, eco-friendly technological benefit. But under real-world conditions, it is creating the exact mechanical environment that destroys your engine's most critical components. The auto start-stop system is hard-coded into your truck's computer to shut the engine completely off every single time you come to a complete stop at a red light, a stop sign, or in heavy traffic, only to fire it back eyes open the millisecond you touch the gas pedal. Ford claims this saves you up to 5% on fuel and keeps the air clean. What they omit is a fundamental law of tribology, the study of friction and lubrication. Your engine bearings rely on hydrodynamic lubrication. This means that as long as the crankshaft is spinning, it pumps oil pressure that creates a microscopic, pressurized film of oil between the steel crankshaft journals and the soft metal babbitt bearings. The metal surfaces never actually touch. However, the exact moment the engine stops spinning, that oil pressure drops to 0 psi. The heavy crankshaft settles, cutting through that microscopic oil film, resulting in direct metal-on-metal contact every single time your truck auto restarts. The engine undergoes a dry start event where the crankshaft must grind against the dry bearing shell before oil pressure can rebuild. A standard engine without this feature experiences about 50,000 start cycles in its lifetime. An F-150 equipped with auto start-stop experiences over 500,000 start cycles. I have personally inspected rod and main bearings on EcoBoost engines driven exclusively with this system active. At just 60,000 miles, the protective overlay on the bearings is completely worn away, exposing the raw copper underneath. Furthermore, this constant cycling places immense thermal shock on your turbocharger oil feed lines and starves the top end of the engine of oil pressure hundreds of times during a simple city commute. The solution is to deactivate this feature the second you turn the key. Make it a muscle memory habit to press the physical deactivation button on your dashboard every single time you start the truck. If you want a permanent fix, you can install a simple plug-and-play inline start-stop eliminator module behind the switch, or use an aftermarket diagnostic tool to disable the feature in the vehicle's computer module. Stop letting a factory programming loop kill your bearings for a fraction of a mile per gallon. If you thought changing your oil more frequently and hitting a dashboard button would save your F-150 from early retirement, you are only scratching the surface. The next two factory configurations are far more insidious because they operate completely in the background, executing orders from Ford's programming that actively dismantle your drivetrain while you cruise down the highway in total comfort. Number 3. The 10R80 transmission skip-shift programming setting number 3 has caused more catastrophic transmission failures and premature teardowns on my shoplift than almost any other design oversight in modern automotive history. Your F-150 is equipped with the 10R80 10-speed automatic transmission. On paper, having 10 gear ratios allows the engine to stay perfectly within its optimal power band. But if you watch your gear indicator on the dashboard during normal acceleration, you will notice something bizarre. The transmission doesn't shift from first to second to third. Instead, under light throttle, the factory programming forces it to skip gears entirely, launching in first, skipping second, jumping straight to third, skipping fourth, and slamming into fifth. Ford engineered this skip-shift logic for one reason and one reason only: to manipulate EPA corporate average fuel economy tests. By skipping gears, the computer drops the engine revolutions per minute as quickly as possible to reduce parasitic drag and squeeze out an extra fraction of a mile per gallon during simulated city driving cycles. But here is the mechanical nightmare that happens inside the gearbox when those gears are bypassed. The 10R80 relies on a complex sequence of hydraulic clutches, planetary gear sets, and a specialized component called the main control valve body. When the transmission skips second or fourth gear under load, it requires specific clutch packs to apply and release at incredibly high-speed differentials. To keep the shift smooth for the driver, the computer forces the internal clutches to slip excessively. This intentional slipping generates intense localized friction and spikes, fluid temperatures at the clutch faces well above 300 degrees Fahrenheit. This constant friction sheds microscopic friction material directly into the transmission fluid. That debris travels straight into the valve body, scoring the highly sensitive aluminum bores and causing the hydraulic valves to stick. Once those valves stick, your line pressure fluctuates wildly. You start experiencing harsh, metal-clinging shifts, severe hesitation, and gear flares where the engine revs freely between shifts. Even worse, this programming causes the transmission to run in 10th gear at speeds as low as 40 miles per hour. This completely lugs the engine, putting tremendous torsional stress on the torque converter clutch and forcing the CDF clutch drum bush to migrate out of its physical position. Once that bushing moves, it blocks the oil passages, starves the internal clutches of lubrication, and completely burns out the transmission. I have rebuilt dozens of these units before 70,000 miles, and every single one showed the exact same pattern of destruction caused by this continuous gear-skipping abuse. The solution to this mechanical sabotage is to change how you command the vehicle to drive. Every time you get in the truck, toggle the drive mode selector into Tau Hot Haul mode or Sport mode. Both of these factory-loaded profiles override the standard skip-shift logic and force the transmission to utilize every single gear sequentially, from 1 through 10. This distributes the thermal load evenly across all clutch packs, eliminates excessive slipping, and keeps the engine from lugging. If you want a permanent solution, so you don't have to fiddle with menus every time you start the truck, you can purchase a high-quality aftermarket custom powertrain calibration that permanently disables skip shift in the normal drive mode, preserving your valve body and extending the lifespan of your $8,000 transmission indefinitely. Number 2. The direct injection only operating strategy. Low-load carbon buildup. Setting number 2 targets the top end of your engine, creating a silent, unlubricated chokehold on your intake valves. If you drive a second-generation or newer 3.5-liter EcoBoost or a modern 5.0-liter Coyote, your truck features a dual injection system utilizing both port fuel injection and direct fuel injection. This is highly sophisticated hardware. Port injectors spray fuel into the intake airstream before it enters the cylinder, while direct injectors spray fuel at up to 3,000 psi directly into the combustion chamber itself. Ford markets this dual system as the ultimate combination of performance and efficiency, claiming the computer seamlessly balances the two to optimize every combustion cycle. What they downplay is how the factory calibration handles low load, low-speed driving, like your daily commute, sitting in traffic, or cruising at constant highway speeds. Under these common conditions, the factory programming defaults almost entirely to direct injection mode, shutting off the port injectors completely to lean out the fuel mixture and lower emissions. Here is the invisible consequence of that strategy. All internal combustion engines experience blow-by, where combustion gases and microscopic oil mist bypass the piston rings and enter the crankcase. To manage this, the positive crankcase ventilation (PCV) system routes these oily vapors right back into the intake manifold to be burned in the cylinders. In a traditional port-injected engine, the fuel is sprayed directly onto the back of the hot intake valves. Gasoline acts as a highly effective solvent. It continuously washes away that oily PCV mist, keeping the intake valves pristine. But when Ford's factory setting runs the engine purely on direct injection during low-load driving, no fuel ever touches the back of those intake valves. The oily PCV vapors hit the dry, blazing hot intake valves and instantly bake onto the metal, creating a sticky, rock-hard layer of carbon crust. Over time, this carbon buildup expands, choking off the airflow into the combustion chambers. Because the restriction develops slowly over thousands of miles, you won't notice it immediately. But by 60,000 miles, the cumulative restriction causes a rough idle, a distinct hesitation when you step on the gas, and a significant drop-off in top-end horsepower and fuel economy. If a large piece of that carbon crust breaks off, it can lodge under the valve seat, preventing the valve from closing fully, causing a catastrophic compression loss and an immediate cylinder misfire. To stop this carbon crust from suffocating your engine, you must break the low-load cycle. First, you need to use an aggressive top-tier fuel system cleaner mixed into your fuel tank at every oil change interval. While this won't clean direct injection valves when the port injectors are off, it ensures that when the computer does activate the port injectors under heavy acceleration, the fuel mixture has maximum detergency to dissolve early deposits. Second, you must regularly introduce a heavy load driving cycle to your truck. Take the truck out onto the highway, select a lower gear manually to bring the engine up to 30,500 to 4,000 revolutions per minute, and perform several wide-open throttle acceleration runs. This heavy engine load forces the factory computer out of its direct injection bias, fully activating the port injectors at maximum pressure, while generating the internal valve temperatures necessary to burn off soft chemical deposits before they petrify into hard carbon. We have overridden the deceptive maintenance intervals, bypassed the bearing-destroying start-stop cycles, and corrected the transmission's self-sabotaging shift logic. But the final factory configuration on our list is the most dangerous because it operates under the guise of a safety feature, quietly executing a strategy that turns your engine into a ticking time bomb. Number 1. The extended coolant temperature gauge buffering setting number 1 is the single most deceptive and physically destructive programming parameter embedded in your F-150's instrument cluster. The buffered coolant temperature gauge. Look at your dashboard while driving. You see a needle sitting comfortably right in the dead center of the gauge, or a digital readout that stays perfectly static. Ford designs this display to give you peace of mind, reassuring you that your engine is operating at a perfectly safe, nominal temperature. But here is the devastating reality behind that dashboard display. That gauge is not a live, real-time indicator of your engine's thermal health. It is a highly filtered, software-manipulated illusion. Ford's factory calibration applies a massive buffer zone to the temperature readout. The programming is hard-coded to keep that needle dead center, whether your actual coolant temperature is a perfectly safe 195 degrees Fahrenheit or a borderline critical 230 degrees Fahrenheit. The computer deliberately hides temperature spikes from you because marketing data shows that live. Fluctuating needles cause frequent and unnecessary dealership service visits from worried owners. This corporate filtering is exactly how an F-150 engine gets destroyed without the driver ever receiving an early warning. In both the 5.0-liter Coyote and the 3.5-liter EcoBoost, thermal management is everything. The cylinder heads are cast from lightweight aluminum, which expands and warps rapidly when subjected to extreme heat. If your truck develops a slow coolant leak at the thermostat housing, a notorious failure point on the Coyote, or if your intercooler efficiency drops while towing a heavy trailer up a steep grade in summer heat, your true engine temperatures will begin to skyrocket because the factory programming keeps the dashboard gauge completely frozen in the center. You have absolutely no idea that your engine is heat-soaking. You keep your foot firmly on the accelerator, demanding maximum power, while your oil temperature climbs past 250 degrees, causing the oil film to shear completely thin. By the time the factory computer finally decides to override the buffer, drop the needle into the red zone, and flash a warning light on your screen, it is already too late. The thermal threshold has been breached. The aluminum cylinder heads have already warped, blowing the head gaskets, and the intense heat has expanded the piston rings until they butt together, scuffing the cylinder walls and destroying the engine block. I have torn down countless engines where the owner swore up and down that the truck never overheated, only for the internal component distortion to prove that the engine had been cooking at 235+ degrees for months, while the dashboard lied straight to their face. The solution to this mechanical deception is to pull back the curtain and monitor your actual live data. If your F-150 is equipped with a high-trim digital cluster, you can use an aftermarket diagnostic software tool to enable the explicit digital temperature readouts to display continuously above the physical gauges. For standard clusters, the most effective fix is to plug a dedicated OBD2 secondary display monitor or gauge into the diagnostic port under your steering column. This allows you to read the raw, unbuffered data straight from the engine control module. The second you see your real-time temperatures climb past 225 degrees Fahrenheit, you know it is time to back off the throttle, drop your speed, and let the system cool down before catastrophic, irreversible damage occurs. The verdict on modern truck ownership, when you add up the realities of modern truck ownership, a clear picture emerges that the automotive manufacturers never wanted you to see. Your F-150 is a highly capable, brilliantly engineered piece of machinery, but it is being actively choked by factory settings designed to satisfy regulatory agencies and post impressive cost of ownership statistics on paper. From the sheared oil of the 10,000-mile maintenance intervals to the dry start bearing wear of the start-stop system, the skipped gears in your transmission, the carbon-choked intake valves, and the blindfolded temperature gauges, the system is rigged to ensure your truck components wear out right as your vehicle payments end, but you do not have to accept that trajectory. By understanding the physical mechanisms behind these features and taking proactive control of your vehicle's operation, you can completely bypass the built-in expiration dates. You don't need a mechanic's degree or thousands of dollars in specialized tools. You just need the discipline to change your oil every 5,000 miles. The habit of disabling fuel-saving gimmicks the moment you turn the key. And the willingness to drive your truck with mechanical sympathy. If this deep dive gave you the real-world clarity you need to protect your vehicle and save thousands in unnecessary shop bills, make sure to subscribe to the channel and hit that notification bell right now. Drop a comment below and tell me exactly how many miles are on your F-150 and which of these factory settings you are going to disable first. Share this analysis with every truck owner you know who is still trusting the factory dashboard blindly. Treat your machine with precision. Ignore the corporate